All right. In this video, we're going to learn how to solve more rational equations, and these are going to be equations where we have multiple fractions or multiple denominators. The previous examples that we just did had a single denominator. Well, this is going to have multiple denominators. So there's going to be more of a process to use here. So I would highly recommend pausing this video and writing down these 5 steps and then hit play when you're ready to hear me talk about it. All right. So these are the steps, again, to solve a rational expression where we have multiple fractions. The first step is you need to make sure that every denominator is factored and then identify the restrictions. So that's going to tell us what x can't equal. And then you're going to look for the LCM, the least common multiple. We've done a lot of that in the previous videos. And then you're going to use that LCM. The purpose of this is to eliminate the fractions. And so you're not trying to rewrite this as a single fraction, you're trying to get rid of the fractions. And we use these common multiple to cancel those denominators out so we can eliminate the fractions. And then once you eliminate the fractions, chances are you're going to end up with a quadratic. And so if that's the case, you want to simplify it and factor it and then solve for x. So again, those are the 5 steps. So let's look at our first example here that you have in your notes. And if you notice the instructions here, it says solve and identify extraneous solutions. So remember, an extraneous solution is a solution that is not in the domain of the original equation. So that means it's going to be part of your restrictions. So we always need to look if that's why we identify those restrictions after we factor the denominator, is because then if we get an answer that falls into one of those restrictions, then that answer doesn't work. All right, so let's look at factoring the denominator, this first one. So we factor the denominator, so the x minus 5 in the first fraction and x minus 3 in the second fraction, is nothing for us to do there. But in this one, this denominator will cancel, or will factor down, because we're trying to find two numbers that multiply together to be 15, that add together to be negative 8. And that's going to be negative 3 and negative 5, because negative 3 times negative 5 is positive 15. Negative 3 plus negative 5 is negative 8, which, if you notice, is also the denominators that we already had. So something that you can always look for. All right, so now we're going to identify the restrictions, so what x can't equal. So x can't equal 3 and x can't equal 5. Because if you did, you'd end up with zeros in our denominators. We can't have those. So those are our restrictions. And let's also identify the LCM. So the LCM, in the first denominator, we have x minus 5. The second one, we have x minus 3. And then the factored form, we have x minus 3, x minus 5. And those are already represented, so we don't need anything more. So that's going to be my least common multiple. All right, so let's look at that first fraction. The first fraction, so again, the next step, so let's look at our steps here. Move this over. So we factored and identified the restrictions. We found the LCM. And so the third step is what we're on right now. We're going to use that LCM to eliminate the fractions. So let's go back up here. So if you look at that first fraction has x minus 5. If I were to multiply, because what we're going to do is we're going to multiply everything by the LCM. Okay, so we could even do this. We're going to multiply everything times x minus 5 times x minus 3. Well, in that first fraction, the x minus 5 and the x minus 5 would cancel out, leaving us with 1 times x minus 3. And then let's look at what would happen with the second fraction. The second fraction, the x minus 3 and x minus 3 would cancel out, leaving us with x times x minus 5. With the last one, the x minus 3's cancel out, the x minus 5's cancel out, so it leaves us with just 2. So notice what happened when we multiply by the LCM. The denominators go away, and we're left with whatever's in our numerator times the other factor. So now we're going to simplify this. Now, if this was a number other than 1, we'd want to distribute that. But otherwise, if we multiply everything by 1, it's going to stay x minus 3. And then distribute the x through, and you get x squared minus 5x, and then it's equal to 2. So what I want to do is I want to write this as a quadratic. So when I write this as a quadratic, I want to put it in standard form, so it'll be x squared. And then I'm going to even subtract 2 from both sides, so I can get this equal to 0. All right, so now when I go to combine like terms, again, we would have x minus 5x, that's minus 4x, and negative 3 minus 2, that's negative 5. So now I want to factor this down. So I want to look to see What two numbers multiply together to be -5 that add together to be -4? Well, hopefully you got -5 and +1, because if -5 times 1 is -5, and -5 plus 1 would be -4. So I'm going to set those equal to 0 and solve them. And I get x equals 5 and x equals -1. Now we want to check for extraneous solutions. Remember that x can't equal 3 and x can't equal 5. So this one here would be an extraneous solution. But this one, since that one does not fall into one of those restrictions, that one would work. So -1 would be our only solution because 5 is an extraneous solution. Let's try another one together. Let's look at this one. 7 is the same as 7 over 1. So if you see just a plain old integer without a fraction, I would highly recommend putting it over 1, so that way it makes it easier to see what to do. This one, the denominators are already factored for us. There's nothing to do in the denominators to factor, so we're just going to jump into that next step, which is to find the LCM. So the LCM in this case would just be x minus 2. Oh, we also got to identify what x can't equal. Sorry, forgot to do that. So x can't equal 2. All right, so let's see what would happen here when we multiply everything times our LCM, which is x minus 2. So with this first fraction, the denominators would cancel out. So x minus 2 times x, or x minus 2, those would cancel out, leaving us with 5x. So now let's go next to the 7. Now, there's nothing to cancel out with, because of the 1, there's nothing to cancel out with the 1, so it just stays 7. And so I would have 7 times, the x minus 2 is still there, so it'll be 7 times x minus 2. And that next denominator, the x minus 2 and x minus 2 cancel out, leaving us with just plus 10. So now we're going to simplify that. So we'd have 7x minus 14, so 5x equals 7x minus 14 plus 10. I'm going to combine like terms. So what I'm going to do is I'm going to subtract 7x from both sides. So I get negative 2x. On the right side, I have negative 14 plus 10. I'd get negative 4. So since we're not dealing with a quadratic, we don't need to get this equal to 0. We can just solve it. We can get the x by itself. So that's why I subtracted 7x from both sides to get negative 2x on the left. And on the right side, negative 14 plus 10 is negative 4. If I divide both sides by negative 2, I get x equals positive 2. And if you notice, that is our extraneous solution. So this one, there is no solution. Because your x equals 2, that would be what we call an extraneous solution. All right. For this next one, we're going to do this one we're going to do this one together again, because this one's slightly different. So let's start by identifying, because this one, if you notice, has subtraction. So remember what we learned about in the previous lesson, that we can look at this as being plus a negative x, so that'll be important. So let's change that to be plus a negative. Make this look better. There we go. And so now let's identify our restrictions, because there's nothing to factor out here or factor in the denominator. So the restrictions are that x can't equal 3. Now the 4 doesn't have a variable with it, so that's not going to give us a restriction. The only time we get restrictions is from our variables. All right, so we get that x can't equal 3, and that's also identify our least common multiple. Now the first denominator, we have x minus 3. Second denominator, we also have x minus 3. That third denominator, we have a 4, and now that's not represented yet, so we need to include that. So that's a little different. So our LCM here is going to be 4 times x minus 3. So now we're going to multiply every fraction by our LCM, which is 4 times x minus 3. So that first one, the x minus 3 and x minus 3 would cancel out. We're left with 4, so we'd have 3 times 4. I'll just write it like that. For the next fraction, again, we have x minus 3 in the denominator. So that x minus 3 and this x minus 3 would cancel out, leaving us with x times 4. And then in that last fraction there, the 4 and the 4 would cancel out, leaving us with x minus 3. So I'm going to have negative x times x minus 3. All right, let's go through and simplify this. So this will be the same as 12 equals, and I'm going to write this as 4x. Distribute the negative x through, so it'll become minus x squared plus 3x. Now I want to get this equal to 0 and solve it. I also want to get my x squared to be positive. So I'm going to move everything to the left side. So I'm going to add x squared to both sides. Okay, so that gives me x squared on the left. And then 4x plus 3x is 7x. So I'm going to subtract 7x from both sides. So that gets rid of those. And then, whoops. And then that 12 is already on the left side, so it's a positive 12 equals 0. So again, always try to get your x squareds to be positive, so in that way it makes it easier. So now we have x squared minus 7x plus 12 equals 0. All right, so let's go ahead and get this in factored form. So what two numbers multiply together to be 12 that add together to be negative 7? Well, that would be a negative 3 and a negative 4. Because negative 3 times negative 4 is positive 12, and negative 3 plus negative 4 is negative 7. And now we're going to set each of those equal to 0 and solve them. And you would get x equals 3 and x equals 4. And if you notice, x equals 3 is an extraneous solution. So that means x equals 4 would be our only valid solution. All right. I think we've tried enough and seen enough examples for you to start trying some of these on your own. So I want you guys to do this first one. So again, there's the factoring step has already been done for you. So I want you to identify the restrictions and find the least common multiple, and then use that to eliminate the fractions. And if needed, write it as a quadratic, factor, and solve. So I want you guys to do this one. And so go ahead, try this, and then pause the video and ready to check to see if you've done it correctly. All right. First, let's identify what x can't equal. So x can't equal negative 2 or positive 2. Okay. And your LCM would just be x plus 2 and x minus 2. So hopefully you got at least those. And now let's go through and multiply everything by our LCM. So in that first fraction, the x plus 2's would cancel out, leaving us with x minus 2, so it'd be 1 times x minus 2. And then in the second fraction, the x minus 2's would cancel out, leaving us with just 1 times x plus 2. And on the last, everything would cancel out, leaving us with just 4. So we'd have x, and this obviously would stay x minus 2, and this would say x plus 2. Or we could look at the left side. X plus x is 2x, negative 2 plus 2 is 0. So we get x equals 2. If you notice, that's one of your extraneous, or that's one of your restrictions, so x equals 2 is an extraneous solution. Oops. So technically, there is no solution for this one, because the only answer that we got fell in that category of being a restriction, so there's no solution for this one. All right, let's end by looking at this one. So I want you guys to try this one on your own, but before we do that, I will remind you that this x is in the numerator, so it's going to be the same as x over 1. So I want you to find out what the restrictions are, find the LCM, and then do what you need to figure out the solutions for this one. This one, there will be some factoring. I'll give you a heads up on that. You will have to factor on this one. So go ahead, pause the video, and hit play when you're ready to check your answer. All right. This one, the only restriction is that x can't equal 3. Least common multiple is also just x minus 3. So when I multiply everything by that least common multiple, the first fraction there's nothing to cancel out the x minus 3, so we're left with x minus 3 times the x. Second fraction, the x minus 3 would cancel out, leaving us with just 6. The last fraction, x minus 3 would cancel out with the x minus 3, leaving us with just 2x on the right. All right, so when I go to simplify this, this will be x squared minus 3x plus 6. I'm going to have to get this equal to 0 anyhow, so I'm just going to do that now. So I subtracted 2x from both sides. So now I can simplify the left side. Negative 3x minus 2x is negative 5x. So let's factor that down. So what two numbers multiply together to be positive 6 that add together to be negative 5? Well, that would be negative 2 and negative 3. Negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. Set those equal to 0 and solve them, and I would get x equals 2 and x equals 3. However, that's an extraneous solution. I don't know why my hand wants to do an A there. There we go. So that's extraneous. The only solution then that works is x equals 2. So hopefully now you have a better idea how to solve a equation, a rational equation, by using that least common multiple and using the restrictions to identify extraneous solutions. So good luck now as you work on your assignment.